My name is Krus, and I would like to talk to you about a security approach that we sometimes refer to as negated blocking or fencing. If you have a microsegmentation firewall and you have the possibility to use security tags as your attribute for putting VMs or containers into security groups, you can use fencing or negated blocking. Let me show you. The first customer that I had, that I started to work with some years back, they had a specific setup. So they had a couple of security zones. They had the semi-trust zone, the trust zone, the restricted zone, the management zone, and infra. So basically a Burton security model. They had a couple of tenants. So they had the internal tenant 1, they had the tenant 2, and maybe they had some more tenants. They also had something that we call an environment. Environment basically is that you have the need for a dev environment, a test environment, and you have a production environment. When you now start to create security policies, there are different ways you can do that. You could use the per use case allow, which means you identify a certain use case, there's a thing talking to another thing on a certain port, and you say allow. Downside of that approach is that you get 5,000, 10,000 rules, and the rule set is growing. So let me show you how you may use fencing or negated blocking instead. So let's start, for instance, with the environment dimension. So imagine that I would like to keep all of these apart one way or the other. In the traditional data center, you would use a combination of VRFs and subnetting. The reason why you do that is because you want to keep things apart, and the subnets is because you want to put a firewall in between. You would like to have the ability to put a firewall in between. But if you have a microsegmentation firewall that can do microsegmentation on the east-west traffic, so on the VNIC of the VM, you can use fencing instead. So the rule set of a security policy in this example would look like this. Imagine that we have a source talking to a destination on a service, maybe with a profile. We say that this rule is applied to something, and of course the rule has an action. What do we do if we get a match on our rules? And then we say, we start here. I create 1, 2, 3 security tags, and if I have a VM, so here's my VM, on the VNIC of that VM, I have an east-west microsegmentation firewall policy rule set. Imagine that I design my rule set like this. On the dev security group, I say if the security group is dev negated, so the exclamation mark here means negated, and the source is any, the service and the profile is any, and then I say apply to the dev security group, and the action is block. What would this mean? Well, this means that imagine that I am a VM. I'm created by hand, or I'm created from a automation portal, and then I say, well, you are a dev kind of VM. This security tags, this individual tag means that on my east-west policy rule set, in this example, I get this rule. This rule says, if you are not dev, trying to do something to me being in dev, I will block you. Imagine that I take my environment dimension, and then I do exactly this. Prod, negated, star, star, star is any, like this, and then I say test, and then I say prod, and use the red pen for blocking. like this. And then I say, hey, this is one of my dimensions that I use in my data center. This dimension I call environment. The cool thing now is that the only thing I've created now is 3 security tags and 3 security policies. But imagine that any VM or container that I create should have either of these tags. And if, for instance, I create a dev VM and I put the dev security tag on that VM gets this security policy that says, if you are not dev, then I block you. Here we go. That means that this is basically 1, 2, 3 VRFs. These are untouchable. You cannot over talk between the different dimensions or sub-dimension in this environment dimension. It's independent of where this VM is running. You can have a VM in Azure or Amazon on DC1 or DC2 or whatever is your use case. It doesn't matter because the security policy will follow the VM since the VM is based on the security tag rather than any other attribute. Okay, so once I've done my first dimension, then it's just going on, because in firewall policy rule set we have a top-down first match kind of approach. But the cool thing now is that if I have 2 VMs and both are in production or both are in test or both are in dev, we haven't said if they and how they, if that case, can communicate. What we have said is that if you're not dev, then I block you. If you're not test, I block you if I am test. So I can now just continue with the next dimension, and imagine that as a next dimension I take my tenants. This is just one use case, by the way. But then the policy rule set would look like this. Tenant number 1, negated, any, tenant number 1, block. If you're not tenant number 1 trying to do something towards the tenant number 1, then I block you. And as you understand, I can now have any number of tenants doing the same thing, and I can, as time goes, I can add tenants without anything changes. Okay, so by now we have a second dimension. That dimension we call, in this particular example, the tenant dimension. The cool thing now is that, yes, I am supposed to tag my VM with the environment tag, but also the tenant tag. But regardless of many environments I have, and regardless of many tenants I have in my data center, I can reuse my security policies. I don't have to create tenant security policies per dimension, per environment dimension, or vice versa. I don't need to create environment blocking rules per tenant, because the tenant number 1 can use either of the dimensions. The tenant number 2 is isolated for tenant number 1, but can reuse the actual security policy. So sometimes this approach is called the write once, never touch firewall policy rule set. Okay, going on. In my example, this is a kind of a network-centric example, but I have security zones, I have tenants, I have environments. My dimensions could be something totally different, but the thing is that now we can actually continue, because at some point we'll say that, okay, cool, I have blocked away the stuff that shouldn't be there. If I'm a production machine, test and dev shouldn't talk to me. If I belong to tenant number 1, the other tenants shouldn't talk to me, right? So sooner or later, I have blocked away everything that shouldn't talk. Now I can use a service dimension, because at some point, of course, the VM should communicate with other VMs or other entities, and they should open up a certain port. So let me give you an example of how that would look like. So imagine that I have this VM. In my example, this VM belongs to tenant number 1. That means that I block away the other tenants. It's belonging to production, let's say, so I block away the other environment dimensions. But I am also, let's say, a web server, or I'm a database, or I am something. So that means that I use the green for an allow rule. Because, for instance, at the furthest down in my policy rule set, I can have my service dimension. And then I can say, with the fencing approach, I can say source is any, destination is any, the service, for instance, is port 80, the profile is HTTP, is applied to anyone with a web tag, and that is allowed. So that means that with the fencing negated blocking approach, I block away a couple of dimensions, boom, 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 and then I say to whomever is left that hasn't been blocked away, I now open up a certain port. In my example, it's port 80, and I call that the web service, but of course you can add any open port, any well-known port or a specific port that you have in your data center. You can create one security policy and a security tag, and all of your tenants, all of your environments, all of your dimensions can use that service tag. You don't need to specify a certain web allow rule per use case. You can do it once, and then you tag your web servers with that particular tag. This is a kind of a network-centric approach. So everything I have here is kind of an old-fashioned design where we said that we have security zones, we have tenants, we have environments, and then we said that we have a bunch of service port for certain functions. Web, we said, DB, we said, maybe we have app 1, we have app 2, or whatever we have, and we call that the service dimension. These are blocking dimensions. This is the final allow dimension. It's a kind of an old-fashioned approach because it's still network-centric. So a more modern example is perhaps that if you're a user, so this is me now, I go to my whatever portal and I click on a blueprint amongst the available blueprints. So I said, oh cool, I would like to have one of those. That means in this example that a bunch of API calls goes away, and I have a web front, and I have something else, maybe with a load balancer, I don't know, maybe there's a database. There are some stuff that corresponds to me pressing that particular blueprint. Okay, so one way to use fencing here is that, well, I know the guy. So that means that I can put the tenant tag to all my VMs. And that might mean, for instance, that all of these could be managed from a certain management network or management something that I have defined. I clicked on something specific. That means that I have a copy of an application. So maybe I put an application numbering kind of tag on these VMs, since maybe I have 1,000 copies of the same application. It's not the same application, it's just identical. So I want to keep them apart, but it's using the same behavior. I have the same behavior from a security posture point of view in all my copies of my application. Okay, we said, of course, that each VM or container or whatever we have is supposed to do something. So I use the green now to open up a certain port. Not all ports, but just the port that I am supposed to do. I can, of course, have multiple ports, and the green tag might mean a span of ports or only a particular service profile, not necessarily a port. Okay, this is a little bit simplified because the problem now is that I'm totally fenced away. Nothing from the outside can talk to anything on the inside here because I use a kind of a waterproof fencing. So maybe I would like to have, maybe this is a web front end or whatever. This is something that should be reachable from something on the outside, whatever that is. What I can do then, using the same kind of negated blocking approach, is that I can say that, hey, you are reachable from the outside, and that outside is defined in this particular tag. Then that outside thing can pass the fencing and reach, in this example, my web front. So in this tag, I basically build into the security, the design of the security policies is that I open up for whatever this is, for this particular one. This is the port I'm communicating in. This is just that I block away everything else. If I have a sequential behavior that this guy here is reachable from outside, he should talk in a specific direction, and maybe there is a behavior looking like this, but I shouldn't talk the other way around. That's kind of easy. I can just use a sequential dimension, and I can say that you are a type 0, you boys are a type 1, and you are a type 2. Unless you are number 0, you cannot talk to number 1. Unless you are number 1, you cannot talk to number 2. And boom, now I have a sequential behavior if this is what I want. Okay, so if you have a micro segmentation firewall that can firewall east-west traffic using something that follows the VM, such as a security tag, it's kind of neat for some use cases to use negated blocking or fencing, as we call it, instead of using a per allow use case. Because maybe you know that, okay, I have an isolated thing here. I just want this thing to not be touched by anything else, so I group them together. They have an internal relationship that looks like a certain thing. They consume stuff in outgoing direction. There is an entry point maybe in incoming direction. It's managed by something. If you let all of these things be dimensions, it's kind of easy to let your cloud management portal just tag the VMs or containers that you create. And since this is infrastructure independent kind of attributes that we are using, then you can now put your VMs or containers anywhere in your environment. It doesn't matter if you have them on-prem or in the secondary data center or in Amazon or in Azure or whatever. They don't overhear unless you allow them to.